Everyone has had a few moments to check their homework. And if you're not here today, those homework answers are posted with today's notes online. There are a few here that I have set up, and were these some of the ones you had questions about, Rose? Okay, so let me tell you my strategy with these, and then let me share with you what my students last period did. On these, because these two are tangent, when they're tangent, we know that they form a right angle because they are perpendicular to the radius, right? At the point of tangency. Now, I look at this whole big figure and see it as a quadrilateral. What do all the angles inside a quadrilateral add up to?
180.
360. 360, like a rectangle would be 360, right? So, if these two add up to 180, then the other two also have to add up to 180. So what I would do to find this central angle here at Q would be 180 minus the 42. And then that would leave me 138. Now that is not how my sixth period did it. What they did, very interesting, they turned these into two right triangles. And so I like it. I like it. So if that was 42, when I draw in the right triangle, it's going to bisect it. That would be 21. So what would it leave us here? 69. And then double it, because that's also 69. And if we double it, we get 138. And that method also works. With my method, these two would have to add up to 180. So I'd get 4x equals 180, so x is 45, and the other one would be 135. On number 31, we were asked to find the measure of ST. It gives us this radius here is 5. Well, if that radius is 5, then this one is also 5. And if I draw this radius into a point of tangency, I know it's a right triangle. So this has to be a 5, 12. It has to be 13. So if this little part is 5, what does ST have to be? So that equals 13, ST would have to be 8. Okay, were you did you do fairly well in the vocabulary and labeling? What about the always, sometimes, never? Pretty good? Okay. All right, we'll review that same type of material as on the review sheets as we get ready for our quiz next week. Okay, if you brought your textbooks with you, which I hope you did. Now, keep in mind, if we look, textbook yesterday, textbook today, textbook Monday. It's nice to have your textbook. All right, yesterday I did most of the notes by looking at the textbook. Today I'm doing the same thing. There's reason, twofold. The first reason is the textbook does a great job with this. The second reason is I think some of you really just rely on what I do in class and don't realize what a great resource your textbook actually is. Now, as you get into more difficult classes and as you go to college, you could go to a class and listen for an hour and a half to a professor talking, and then the test he gives or she gives the next week has absolutely nothing to do with anything they discussed. And it was everything that they had in the assigned reading. So we need to kind of get used to being able to research things on our own and get a lot of stuff out of it. We also have a lot of people right now that are in the middle of fabulous spring sports because you're so awesome and you're doing well and you're missing class a lot. So using that textbook as a resource is a valuable tool. All right, so today we're looking at central angles and arcs. A central angle is an angle whose vertex is at the center of the circle. So let's draw one. Here's a circle. There's the center. Whoops. That right there is a central angle. It's just an angle whose vertex is at the center of a circle. And I'm excited to see most of you taking notes right now because the quiz next week will be open notes. And that doesn't mean you can go home and print out my notes. They have to be your notes. Yes, ma'am?
Do I have to take them out of my notebook?
No. You can use your notebook. You just may not use your textbook or your technology. Okay, so that central angle is an angle whose vertex is at the center. Now, an arc is just an unbroken part of a circle consisting of 2 points called the endpoints and all the points between. So we also have an arc, and we actually have an arc that's formed where this angle intercepts the circle. Do you see that is an arc? It's just part of a circle that's formed by 2 endpoints and all the points in between. That's an arc. Now, the book has divided an arc into 3 different categories. The first category is a minor arc. And with a minor arc, so I'd say a minor, don't scratch through it, underline it. A minor arc has a measure that's less than 180 degrees. So we measure arcs in terms of degrees, the measure of an arc. Now, next week we'll actually look into arc length. That would be like if you took out a tape measure and you put it around the circle and you figured out how many centimeters long it was. That's arc length. This is the arc measure, and it's in terms of degrees. A circle is how many degrees? 360. So if we have one that's less than 180, it's considered a minor arc. Now, the measure of an arc is equal to the measure of the central angle. The measure of arc AC is equal to the measure of central angle ABC. So this arc is the same. So if I said the measure of this central angle is 70 degrees, then the measure of the arc would be 70 degrees. Now, a minor arc can be named with 2 letters. So we can say the measure of arc AC. And this is a symbol in math that just makes total sense. An arc is denoted with an arc. Now the next one is a major arc. And a major arc is an arc whose measure is more than 180 degrees. Now with a major arc, it's named with 3 letters. A minor can be named with 2. A major needs to have 3. So here we have an arc ADC. Do you see how it's highlighted in red? That's a major arc because it's more than 180 degrees. Now, if this central angle right here were 50 degrees, what would it leave out here for the rest of it?
130.
What is 360 minus 50? 310. 310. So the measure of our ADC would be 310. If this were 50. It doesn't look like 50. But.
Still thinking 180. So.
Oh, gotcha. All right, and then semicircle. You guys have known that word for a really long time. A semicircle is how many degrees?
180.
It's exactly equal to 180 degrees. And so it's also named with 3 letters. Okay, any questions about how the measure of a central angle corresponds to its intercepted arc? They're the same. And then any questions about the 3 categories of arcs? Less than 180, minor. Greater than 180, major. Equivalent to 180, semicircle. If it's less than 180, that's the only kind that you can name with 2 letters. The other 2 would need 3 letters because you have to explain which direction you're going to. So if I said arc AC, I'm referring to this. If I said arc ADC, then I'm referring to that, or CDA. Okay, this is one of those common sense things. The measure of an arc formed by 2 adjacent arcs is equal to the sum of their measures. So the measure of arc ABC is equivalent to the measure of AB plus the measure of BC. Now, I took this problem and I blew it up really big on the next page. And we're going to work through it and find every central angle. And then if we know the central angles, we obviously know the intercepted arcs. Okay, so here's the big picture. All right, if this angle is 18, then this angle is 18 because what kind of angles are they? Vertical. They're kissing angles. Vertical angles.
90.
All right, if this one's 90, those 2 together have to add up to 90. So what is this angle?
Teachers, please excuse the interruption. The thing that's happening is this from the cafeteria and should be in their 7th period class at this time. I see a lot out in the hall, so hopefully they'll be in your classrooms shortly. Thank you.
Okay, do you see that this is a semicircle, AED, so that's 180 degrees, right? So if this little part is 18, what does it leave for this central angle AFE, this big one right here?
162.
162. So now we have all the measures of all the central angles. So I could ask you, what is the measure of arc AB? 18. It's equivalent to its central angle, 18. Okay? What is the measure of arc EAC? Good, 252. So what I would do in my brain probably is to do the 162 plus the 90. I'd add up this arc here and this arc there and get 252. So that was that obvious one we looked at just a second ago. All right, now, is this the same as arc EAC? Is that the same as arc EC? No. EC has to be less than 180. It has to be the minor one because I just named it with 2 letters, doesn't it? So what would it be?
108.
108. 90 plus 18 is 108. Okay. We're good with that? All right. Now, on this one, 3 different things that all kind of sort of go together. If we have congruent central arcs where they intersect the circle, central angles, excuse me, where they intersect the circle, do you see that it actually forms chords? We could form chords. Well, since they're congruent central angles, these chords are also congruent. That's what this first statement says. And if the chords are congruent, then the arcs are actually congruent. So if the arcs are congruent, what do we know here? The angles have to be congruent. It's almost like the transitive property, isn't it? If 1 equals 2 and 2 equals 3, then 1 equals 3. I would probably just draw one picture. Hopefully y'all can draw a better looking circle than I.
It's the first rule.
Okay, so if this is congruent to that, then that is congruent to that, and that is congruent to that. That's terrible looking. Huh? You think so? It definitely is a disaster. Okay. Are we good? All right. You got practice with that on here. Homework. So, if these two chords are congruent here, RS is congruent to TU, that also tells me that this arc RS has to be congruent to arc TU. So if they tell us that the two chords are congruent, we know that the two arcs must also be congruent. So if we know the arcs are congruent, could we just set these two things equal to each other? Hold on. That's a plus. And so x equals 27. So if we wanted to know this measure of that arc, we would just plug in 27. So 3 times 27 tells me that the measure of arc ST is, that should be a 3, it looks like a B. 3 times 27, or 81 degrees. Make sense? Excellent. All right, and then really the last topic today says that if a radius is perpendicular to a chord, it's going to bisect the chord and it bisects the intersected arc. So if a radius is perpendicular to a chord, it bisects the chord and the intersected arc. And then vice versa. If we have a chord that is bisected and perpendicular to another segment, this segment that it is perpendicular to is the radius. Or if it goes all the way through the circle, then it is the diameter. Okay, so how does that help us? This is definitely an SAT type question right now. So if they gave us this picture and they ask us to find BD. Now when they say find BD, what that means is, with no segment over it, it means the length of BD. So if it doesn't have that segment bar over it, it's asking you what is the length of this segment. All right. Now, what is the length of radius AE? 5. Then every radius of this circle would also have to be 5, wouldn't it?
Yes.
Do you see that this just created a right triangle? It is a 3, 4, 5 right triangle. Now, if a radius is perpendicular to a chord, then it bisects that chord, doesn't it? So if this side is 4, this side must also be 4. So the length of BD is 8. That was straight, this question, identical to ones that are in SAT study guides. Yeah. Okay. That's all we're going to go over today. So you have the remainder of class, which is only like 7 minutes, but you could get a good bit done. It's Friday. You don't want to take homework home. Page 404. Now, guys, on your calendar, there is an erroneous comma right here. This should be 47 through 49. It's not 47 and 49. It's 47 through. There's an erroneous comma on your calendar. Okay, look up the word and see what that means.
Milestone study guide, Sylvie.
Huh?
The milestone milestone study guide?
We did that.
I don't know what do you want us to do?
You can throw it away.
Okay.